So let us consider the IUPAC rules for naming ALKOXY. The suffix ane from an alkane can be replaced or is replaced with an OXY, that's oxy. And then the alkoxy group is named as a substituent of the parent alkane without a space between the alkoxy group and the parent alkane. For instance, if I have CH3 or CH3, now I can pick this to be the alkoxy group, and then this is the alkane group. So I can simply name this methoxy methane. So now notice that this is a methane group and this is a methane group here. Now the methane here, I can simply go ahead and replace the ane with an OXY, and this becomes methoxy. So I'll simply name this compound as methoxy methane. So also I can have a compound like this, CH3, CH2, or CH3. So I'll go ahead and pick this to be the alkoxy, and then this is the alkane. So I'll simply name this by naming the alkoxy group first and then the alkane group. So this is a methane. I'll remove the ane and replace with an OXY. So I'll have methoxy, and then this is an ethane. So I'll have methoxy ethane. So now notice that this is written together and not this way. Methoxy ethane. This is wrong. So this is how we should write this. Alright, so let's go ahead and see further examples of alkoxy group. So before that, let's look at the second rule. The second rule says the position of the alkoxy group is allowed the lowest possible number with respect to the parent chain. So if, for instance, I have a structure like this, and then probably I have the alkoxy group somewhere here. Let's say OCH3. So this is CH3. This is CH3. So if I round this as 1, 2, 3, 4, 5, 6, 7, and 8, you will notice that the alkoxy group will be at carbon, right? So what if I start at 1, 2, 3, 4, 5, 6, 7, 8. So you notice that the alkoxy group is at carbon 2. Now it's at the lowest possible position here. So I'll simply go ahead and name this way. So this is an 8 carbon alkane, whereas I have my alkoxy group here, which is OXY. So I'll go ahead and name this a methoxy. So let's say methoxy, but then it is at carbon 2, so I'll call it 2-methoxy. So now what's alkane is this. This is 1 2 3 4 5 6 7 8, which is an octane, so I'll call this 2-methoxy octane. So that's the correct name for this compound. So I'll go ahead and wipe this. Let's look at other examples. So I have 1 2 3 this way, and then I have this way, and I have O, and I have this way, and I have CH3, then I have this. Okay, let me add one more of this here, and then CH3, and then so when I look at this, if I number from here 1 2 3 4 5 6 7, so you notice that the alkoxy group will be at carbon 6 here, but if I number the other way around, I'll have 1 2 3 4 5 6 7. So you notice that the alkoxy group will be at carbon 2. So this is the right way to number this. So I'll go ahead and look at the alkoxy group. I have 1 2. So notice I have 1 2. So this shows that the alkoxy group is an ethoxy from this chain. So I'll go ahead and name this 2-ethoxy. So this is a 7-carbon chain alkane, which is a heptane. So I'll go ahead and call this 2-ethoxy heptane. So this is how simple it can be. So let's quickly look at one more example, and then we'll move over to the next. So in this example, let's say I have 1 2 3 4, and then 1, and then I have this, and then I have CH3, and then I have CH3. Now if I number this from 1 2 3 and 4, so you notice that this will be at carbon 1, and then I can simply go ahead and call this 1-methoxy butane. Alkoxy groups have a trivial name that are obtained by adding ether to the alkyl groups attached to the oxygen atoms. For instance, if I have, let's say I have this, so this is CH3, this is CH3, so this should have been 1-ethoxy ethane. But then it can also be named as diethyl ether. So next we'll talk about the IUPAC rules for naming aldehydes and ketones.